Hi there, and thanks for joining us for this webinar on mastering the art of effective Socratic dialogue. My name is Francis Vigent. I'm a former teacher, and I am a co-founder and CEO here at KnowAtom. If you're on the live session, there's an opportunity for you to ask questions at the end, and I'll do my best to kind of move through this quickly. The way to ask questions, or if you need some clarification, on the right side of your screen, typically there'll be either a question box or an orange arrow that you can click to show the questions panel. So if you drop those in there, I will do my best to get to them as we go. Another thing to keep in mind is that we have several handouts. There are 3 handouts that will be a part of this. There are several tools that I'll be referring to later in the presentation. So if you're on the live webinar, you'll be able to download those as well. Okay. So quick overview for you here. I'd like to kind of break this presentation down into 3 areas. One is why even have a Socratic dialogue? 2 is how to get students actively participating in that Socratic dialogue. And 3, what are the concrete steps that you can take to really ensure that students are making deep connections in something like a Socratic dialogue? So try to make this as practical and concrete as we go. But again, if you have any questions, feel free to ask. So jumping right in. Why Socratic dialogue is so important in a next generation science classroom really has to do with the fact that a next generation science class is all about learning how to work with ideas. Not only your own ideas, but the ideas of others. So when we think about science and engineering practices, when we think about these new standards as being 3-dimensional, a lot of people struggle with the idea that these 3 dimensions are really happening simultaneously, that they're all part of performing the expectation of the standard. And so Socratic dialogue is an opportunity to have students step into the content context, the actual phenomena that's driving, and that's how phenomena starts to drive teaching and learning, is that students step into that real world context and then they begin to develop questions, to begin to identify problems. And what's really important here is that they then work with those ideas to refine them, to answer them for themselves, but they also need to consider the ideas of others. And so Socratic dialogue gives us that opportunity very early on in a lesson, okay? When we talk about effective Socratic dialogue, it's important to realize that these new standards come with a new definition of effective science instruction. And so I want to point that out to you here. And this comes right from the National Research Council, which underpins all of these new standards. And this has been around for a while. It's been out for 7 years, so not anything new. But this is their definition, that effective STEM instruction capitalizes on students' early interest and experiences. It identifies and builds on what they know and provides them with the experiences to engage them in the practices of science and sustain their interest. So what we're talking about here is a shift from what you see in the picture on the left to what you see in the picture on the right. Specifically, it's moving from an I-do model to a you-do model. Okay? Demonstrations and having students engage in dialogue, which is really focused on finding a fact, recalling a fact, matching a word with its definition. That's not a Socratic dialogue, first of all. Second of all, under these new standards, it's not effective science instruction, okay? So what you see on the left is not equal to what you see on the right. What you see on the right are 2 students working together in a pair. This is actually a KnowAtom classroom on the right. What they're doing is they have gone through engaging in anchor phenomena in Socratic dialogue, but now they're working with their own ideas even further, because a Socratic dialogue leaves students perhaps with questions that have been answered and some that have been refined, but nonetheless it still leaves them with questions, which it lays the foundation of the work of a scientist or an engineer. Okay, so they're not, whatever they're doing, it's not the result of a demonstration like the students on the left in these colorful t-shirts here. The students on the left are seeing what they're supposed to go and do next. The students on the right are engaged in developing their ideas together, okay? And before doing it on hands-on, Socratic Dialogue gives us an opportunity to do it intellectually in a group sort of discussion. So key features of a genuine Socratic dialogue, I'm trying to break this down into, there's many sort of telltale signs of a genuine Socratic dialogue, but these I think are the 5 most important. First of all, students are discussing what they think and specifically why they think it, okay? And they're doing it as part of a group discussion, not as part of a individual turn and talk. And what's important is that the teacher, this is an opportunity for formative assessment. So the teacher needs to have visibility on that discussion. Okay, so the difference here is that if students are discussing in a turn and talk, at most the teacher can have visibility on maybe 2 of those, but it's really not Socratic dialogue at that point. Number 2, it requires listening and thinking. There's a difference between listening or waiting your turn to talk. It's a big difference. The other thing is it's not only listening to what's actually being said, it's thinking about what's said and then forming a question related to what you think the person meant, or if you feel like you understand what they meant, maybe something to clarify, something to add on to it, maybe a piece of evidence that appears to disprove the claim that they're making or is contrary. Okay, that's absolutely a requirement, listening and thinking. It requires teachers and also students, but I mentioned teachers here specifically because I've seen on many occasions where students will contribute an idea and the teacher will sort of shoot it down. It's really important that teachers and students take ideas seriously. And that if you don't take it seriously, you can't work with it. We can work with all ideas, whether they are valid or invalid, factually or sort of accurate or inaccurate. So this is really important. Number 4, a Socratic dialogue should be something where students are developing the practices through this, but also learning expectations, learning how to conduct themselves in this type of environment where students are sharing ideas, where a teacher is acting as a moderator or so on. It should be able to be student-led at some point, even in a kindergarten or first grade class. And I'm going to show you some different models in a moment for how Socratic dialogue can happen, but at these different levels. But it's really important to understand that the goal here is students developing creative, analytical, and evaluative thinking skills, okay? Because those are the tools that scientists and engineers need to use in order to develop and use content. And that is the foundation of these new next generation science standards, regardless of if you are an adaptive or an adoptive state. Number 5 is the role of teacher. The teacher is the coach with these new standards. And what they're doing in a Socratic dialogue is they are coaching skills, Socratic dialogue skills. And they help make sure that that the discussion is being conducted in a fair way, that the rules are being followed, that if things move too far off topic or dwell too long on a single issue, that they can act or interject in that discussion as an interested skeptic and help pivot towards another key idea which is related in the storyline. Okay, so this is also relevant. I mean, today we're talking in a scientific context or engineering context in a K-8, K-12 classroom, but these skills and what I'm talking about today is just as valid in social studies and English language arts, literature classes at all these same grade levels. And if you have questions around that, if anyone's joining from another content area, I'll try to give some examples here in a minute, but feel free to ask and I'll do my best. So a Socratic dialogue, and this is where some folks get a little bit bogged down or perhaps misinterpret. So a Socratic dialogue is not a vocabulary or reading drill to find information from a text, whether it's an informational text or not. It's also not something that can be scripted as questions you wrote, or that you pulled out of the curriculum or whatever and put into a PowerPoint or a flip chart or Quizlet or Kahoot. These things do not constitute a Socratic dialogue. Why? Because a Socratic dialogue, remember, requires listening, and then the question that's asked is related to what was heard and what we think we understand as a result of what we listened to. And that requires thinking, okay? You can't create a script that does that, okay? Also, kind of similar to the vocabulary and reading drill, but not focus on what style questions that are in, some what questions are better than others, but oftentimes teachers are focused on asking students, well, what is this? What is that? That's all fact identification. Okay, that type of questioning does not lend itself to Socratic dialogue. And unfortunately, that oftentimes is the majority of the kind of questions that we see in a science or engineering classroom or STEM classroom. Okay. Number 4, the role of the teacher is not to be the primary questioner, with the student acting as the primary answerer. Okay. The goal here is for students, again, to develop the skill to be able to question themselves, to question each other, and to also answer their own questions and to answer questions of others using concept to concept, concept to self, concept to world connections, and also, most importantly, evidence. Okay, so that's the role that fact plays. It has evidence. And in particular in science and engineering, that evidence is evidence we're gathering through experimentation. I'm at a loss for words here. Not anchor phenomena, but our observational experiment phenomena, which is sort of a thread of that larger anchor. So why Socratic dialogue in the next generation science class? Well, it empowers students to participate in actually developing their own idea and working with the ideas of others rather than being more passive participants. Okay. Second reason is that it engages students in numerous science and engineering practices, and I've bulleted out a few of the specific ones here. Asking questions, analyzing and interpreting data, constructing explanations, engaging in argument from evidence, obtaining, evaluating, and communicating information. And again, remember that obtaining, evaluating, communicating information is something that happens in discussion. But as students plan their investigations that are based on the questions that have gone unanswered, now they're going to gather firsthand data from real phenomena, if it's hands-on. And then that data is something that they're going to be able to analyze, interpret, use as part of constructing explanations, and so on. So you can hit these practices on multiple levels: verbally, kinesthetically, visually, and so on. And it integrates into ELA as well in terms of the way these things get expressed. Third, it allows students to make authentic connections to scientific concepts. And this is what I referred to earlier. An authentic connection is one that is obviously not the result of direct instruction. So if you're creating this culture of Socratic thinking in your classroom, then this over the course of 10 weeks starts to become the way that you do business as a student scientist or a student engineer in the classroom, is to think about other things that we've thought about before. Maybe there's a connection here. Maybe there's a connection to my own life. Maybe this connects to the world around us or somebody's world that I can, think of. And so these are all very key. The fourth one group discussion like this in a effective Socratic dialogue exposes gaps in students' individual thinking, and it helps those individuals to refine the kind of questions and thoughts that they had, or even problems they've identified. So I'll give an example from sort of like an upper middle school, high school social studies context, okay, something outside of even science. So there's a book called America Walked Into a Bar, and it's been written up by Smithsonian Magazine and so on and so forth, and it's actually a history book. And what it does is it traces American history from the colonial times to the present, and how specifically bars played a role as a crossroads for thinking and so on. So you could, in the social studies class, ask people, or ask the students, why do you think, if you said, this is sort of saying that America grew up in a bar. So you could say to the class, well, how could it be, or why do you think somebody would focus on America growing up in a bar? And, the knee-jerk reaction might be, a very simplistic reaction might be to say something like, oh, well, maybe, in bars people drink, and so, they're more likely to share their opinions, and so, this was a place where, for that reason, that, things happened related to American history, because it was just sort of a wild and crazy place to be. And so that's, maybe one level. But if you push further and start sort of thinking about it, you might get other answers like, well, bars, the way we think of them today, is not the way the bars have always been. In fact, bars used to be called taverns, and back in colonial times, the place where everybody would congregate would either be church or at a tavern. A tavern served as a hotel. It served as a restaurant. It was a place where both men and women were allowed to go together and to meet. And so, yes, maybe people drank or things like this, but what was most important is that this became a place where different people, different ideas had an opportunity to intersect, and those ideas could evolve and people would share their opinions. And it also, by virtue of being a place where travelers would stop, became a way to distribute ideas, not necessarily that it was somebody's, deliberate attempt to distribute the ideas, but it just happened by chance. And then, so you could actually follow this forward. And so in a social studies context, something, we could ask how could those ideas be distributed? Why would somebody who had a big idea maybe want to go around and stop at these sort of colonial taverns and to tell their story, to tell their idea, to begin developing support? How could that be the foundation of a revolution? And where would you expect people to go from there, and so on? And so you could kind of play this out more and more. But the key here is that somebody might come up with that simplistic idea, because that's where people drink and they're silly. But on the flip side, there's actually some real thinking we can do about the dynamics of how that would work. It's also kind of an interesting book, so I'd mention take a look at that. But connecting back to science, what's important here is that Socratic dialogue is the perfect basis for experimenting and prototyping because it acts as a springboard. It leaves students with more refined ideas, more informed opinions, because they've had this sort of iron sharpens iron group discussion where they presented their ideas and other students have added onto it or helped refine it in such a way. And it's a springboard into the work of scientists and engineers because scientists and engineers are developing answers to questions and solutions to problems through experimentation and prototyping. Okay, so students then leaving a Socratic dialogue and going into planning an experiment and then carrying that out hands-on is exactly mirroring the work that scientists and engineers do. Okay, some of the questions can actually be tested in the classroom. And it's relevant because it's the direct result of students' own thinking. So I would think about it like this. If you're a KnowAtom user, you're familiar with this type of arc. If you're not, this is one way to think about it. So think about a nonfiction reading as being something that begins to get that anchor phenomena out there, okay? But then you're moving towards investigative phenomena, but before you get there, you want to talk about those concept to concept, concept to self, concept to world connections that students already have, okay, through the text, through video, through, could be any other, through looking at materials and so on. So out of the very first glimpses of anchor phenomena, students begin to generate questions or identify problems. So that's where the questions and problems arise. The Socratic dialogue is where those questions begin to get answered, in some cases if they're very simplistic, or refined, okay? And when they're refined, they can be refined further and potentially answered through the experimenting and prototyping. So that's why you see Socratic dialogue sitting between reading and other media forms of interacting with anchor phenomena, and where students begin setting up for and actually interacting with investigative phenomena. And I'm not going to get into this today, but what I would say is that the final section here, the conclusion, sharing, debrief, so on, that it can also mimic a Socratic dialogue as well. I'm just not going to focus on that specifically today. Somebody asked what was the name of the book that I was mentioning, and that's called America Walks into a Bar, I think it's called A Spirited Look at American History in Taverns, Bars, and like grog houses or something like that. If you send me an email, I'll send you a link. Nonetheless, Socratic dialogue is really important in terms of the layout of your class and how you organize students, okay? What I'm going to talk about today are 3 different formats for Socratic dialogue, depending on your grade level and the familiarity of your students with Socratic dialogue. You may want to focus on one and then transition into others, okay? So the first sort of classroom organization logistically that I call the Wonder Circle is an open circle discussion, okay? This is best for a kindergarten, first grade setting. Could be, even early second grade setting, like when students come in September, October, early November. This is where the teacher uses a Socratic sentence starter to model how to take risks and give ideas. So this would be obviously at the student's level. And I'll give you a little kind of sense of what that's like. So picture here the teacher sitting in their chair or sitting on the floor, and then all the students, crisscross applesauce on the floor on the carpet in a circle. Now, I don't want you to infer from my diagrams here that this means you can only do it with a classroom of 10 students. You can do this with a classroom of 30 students. Just for the sake of space, I've drawn fewer here. So here's my example. So teacher would potentially start with something like a wonder, okay? So we might call this a wonder circle for that reason. She might say, I wonder if trees grow in winter. And the next student in line in that circle, okay, so I wonder if trees grow in winter. There's sort of 2 ways to proceed. The teacher could set it up that everybody goes around that circle and also gives a wonder. You can see how kind of kindergarten appropriate this would be. Or she could have the students go around the circle and share what they think, actually responding to the teacher's wonder, okay? So imagine the teacher put up this visual and she said, I wonder if trees grow during the wintertime. A student might say, I wonder why some trees lose their leaves and other trees seem to keep them. Another student might say, I wonder if trees need water in the wintertime, so on. If the students were responding to the teacher's wonder, I wonder if trees grow during the wintertime, student may say something like, I think trees without leaves don't grow in winter. Another student might say, I think trees with needles do grow in winter. Another student may say, I think we could measure a tree at the beginning of winter and again at the end of winter to find out. So this is a way of actually going around a circle, okay, in something like a kindergarten, first grade, even an early second grade class, with a teacher sort of modeling by presenting their wonder and then maybe prompting the students to use a different Socratic sentence starter in order to respond or to mimic that teacher's behavior. What I'd like to also add on to this is that these types of circle, I call them wonder circles, this open circle discussion, can be coupled with nonverbal class participation. So an example of that would be that if a student says that they wonder whatever, they think whatever, other students who had the same wonder or the same thought could quietly and gently pat their self on the chest, sort of visually, to signal to the rest of the class that they had the same wonder, the same thought. Okay, and those sort of nonverbal student class participation techniques, I mean, those are relevant all the way on up, but here they can be especially helpful. Second format is the teacher acting as active moderator. Okay, this is where the teacher releases more responsibility to students for questioning and answering in something that's a lot more dynamic than that kindergarten, first grade sort of circle discussion that I was just mentioning. And I'm trying to explain what I mean by active moderator. Where this would apply would be essentially if a student, second grade on up, or if you have mature K1 students, first grade can usually handle this towards the end of the year, but if you have a mature group toward the end of the year, so on, you might even be able to get some of this going with kindergartners. But absolutely third grade on up. Acting as active moderator for the teacher is important because in this particular environment, it's helping activate students. And that's important when students are total rookies to the idea of a Socratic dialogue and what the expectations are. And you have to remember, if students don't understand the expectations or they're new at taking risks, the teacher has to be the first to ask a question and then bounce ideas off different students and sort of help model what it looks like to chase a concept, okay, and what it means to build off of other students' responses. So, and act as a coach in that. So I'm going to try to show you a little bit of what that might be like. Okay, so picture like a third grade class. And let's say my third grade class, I'm going to display this visual. Okay, so I walk into my class, I display the visual, and I'm going to ask the entire group who are situated like this, okay, around where I'm sitting, they're all sitting at their desks or so on. And I'm going to say, why do you think this bird is called a goldfinch? And so you may see, students kind of look at each other for a second, and then you're going to get that one student who says, well, it's yellow. And yellow looks like gold, so it makes sense that they would call it a goldfinch. Maybe finch is the kind of bird. Okay. So you can see here very brightly yellow. Okay. Now, what if I pull up a picture like this? This bird is not yellow like this bird, a little more green. So it kind of blends in with the background, maybe a little bit of yellow. What would you say if I told you that, or before I even got to that, I'd say, well, is this a goldfinch? They might say, well, probably not. Or they might say, yeah, maybe it kind of looks like the other one. So, well, why do you think they're, for anyone who thinks it's different, why do you think it's different? Or for anyone who thinks it's the same, why do you think it's the same? And so what I'm trying to do here is I'm trying to get the students to explain their thinking. They say, well, I think it's different because this one looks more green and it's blending in with its background. The other one was clearly bright yellow. Okay, maybe this is called a green finch. Maybe this isn't even a finch at all. Okay, student may say it's a baby one. Maybe it's not a full adult, so it hasn't gotten its bright yellow. Another student might say something like it's a different species. That's sort of like the greenfinch idea. Okay, so what I'm encouraging by this focus on creating, evaluating, and analyzing through my questioning is not just the bird and the characteristics, but I'm asking students to explain what they think and why they think it. And then I'm acting as active moderator because I'm going to say at this point, well, what if I told you they're both adults and they're both goldfinches of the same species? So students now would have to think, well, that eliminates a lot of the things that we thought might be the issue. What's left? And so you might get to, after a couple of seconds, well, maybe one's male and one's female. So then you can kind of move forward and say, well, okay, why do you think there might be a difference between males and females of the same species in terms of their coloring? Like this. And so, you know, that's where you, if the purpose of our unit is related to, let's say, inheritance and traits and so on and so forth, now we're actually stepping exactly into the context. It's real world phenomena here, right? These are real birds. They live in real ecosystems. Their coloring is really like this, okay? And it serves a real purpose from an adaptation standpoint. So why is that? Let's think about it. And so, you know, we step into that. So students, you know, maybe predator and prey relationships, camouflage, being able to distract predators from the nest. If the mother bird is in the nest with baby birds that are unable to move from the nest and defend themselves. And then we say, well, you know, is there any other evidence of something like that in nature? You know, could we make this connection to something else? And so, you know, depending on the tools you have available, and I'm going to kind of show you how that works in a second, you know, students may say, well, yeah, actually, what about mallards? You know, male mallards are very brightly colored and female mallards are very camouflaged. So that actually seems like it mimics, in some ways, the same sort of thing that we see here, a brightly colored male and a camouflaged female. So again, using that Socratic dialogue as active moderator, what we can do is we can start with something basic, but by asking the right type of higher order question and creating that safe space for risk taking and building on each other's ideas and having things like sentence starters to help support students. What we do is we get students working with their thinking and actually developing it and refining it. And that actually has benefit when it comes to unanswered questions, when planning experiments and actually carrying them out. So I'm going to show you the third format. So I said that there would be three formats that I would show you. So the third format is called inner circle, outer circle. Okay, and what I have here, and I'll show you a larger version of it in a moment. So the inner circle, outer circle format is where the teacher acts as a passive moderator. Okay, in the previous example I gave you, active moderator is where the teacher was really getting in there and actively provoking students to respond by asking those questions. In inner circle, outer circle model, the teacher is really acting as somebody who's there passively making sure that the rules are being followed, that the conversation is remaining largely focused, and that the students are transitioning through key ideas that are important to that particular lesson. Okay. This is where students have the maximum release of responsibility. This is where students are responsible for questioning each other and answering each other in the greatest release of responsibility. In the prior example that I gave, that's absolutely acceptable. That's what you want. That's what you're pushing students for. But sometimes you have to use an active moderator model for a couple weeks to get students up and running with the basic expectations before you can add sort of a new layer of responsibility onto the students. Okay, this is particularly useful for grade 3 and up. And we have some technology integrations that we use. We have a platform at KnowAtom we developed called Socratic, which allows there to be a class-wide Socratic dialogue happening simultaneously. I'll explain a little bit about how that works, but not too much. So I want to explain how an inner circle, outer circle discussion actually takes place. Inner circle, outer circle, Socratic dialogue. So what happens here where you see in yellow, this is the inner circle. The inner circle has a verbal discussion going on. It's using Socratic sentence starters, the Socratic questioning techniques. These are all students, okay? You can see the teacher down here is acting as moderator. They may have some seed questions. What I mean by seed questions, it's a question if the group gets stuck, where they're not really getting momentum, or maybe they didn't consider a particular big idea in relation to something. A seed question is a higher order question that a teacher could interject at some point in the discussion to help pivot that conversation either back on track or towards another big idea. Okay, that's key to these particular concepts in this particular lesson. Okay, so the focus on using specific Socratic questioning and answering techniques with these sentence starters is at its highest level in this type of Socratic dialogue because it is that full release of responsibility. What happens in the outer circle is nonverbal. Okay, now the outer circle uses, in our case, peer evaluation sheets to hold their partners accountable who are on the inner circle. So you can imagine this student is partnered with that student. It can also happen where this student sits next to that student, okay? It's just that one of those students is verbal on the inner circle, the other one is nonverbal on the outer circle. Now, what that student's doing with that peer evaluation sheet, which we co-developed, helped develop with some of our users in Wisconsin, in Bayside, Wisconsin. This peer evaluation sheet is about holding the student who's in the inner circle accountable and to provide that student with feedback. So it's a kind of formative assessment that's based on what that student has done in the moment and then which they can use in the very next Socratic dialogue, okay? So I'm going to show you what some of these tools look like, and I can come back to that visual. So this is what those Socratic dialogue sentence starters look like. So if I need help understanding, here are some sentence starters that students can use to get help understanding in the context of a verbal or even nonverbal Socratic dialogue. Same thing if we're looking for evidence to support a view or higher level questioning, changing the subject, building on others' ideas, agreeing or disagreeing. If we believe somebody's making an assumption, or if we believe somebody needs to be involved in the discussion, the dialogue that hasn't had a chance to contribute, or who we think may have a different idea, and then expressing opinion, okay? These are the key areas. And actually, these sentence starters can be scaled down to kindergarten. You can use slightly less complex sentences or the more simplistic ones that are here, and they work fine. Obviously, as the students are getting to third grade and then beyond, this should be part of their Socratic discussion repertoire. Okay. Now, I mentioned peer evaluation. This is what I was mentioning we had contributed to with our colleagues in Wisconsin. So imagine the students in the outer circle acting as evaluator, and the participant is their partner on the inner circle, date, unit, lesson, so on. They're recording how many contributions their partner is making to that discussion, okay? Are they making none? Are they totally hogging the floor? Okay. Another piece, this is set up like a rubric, okay? are they meeting their ultimate goal, or are they experiencing stumbling blocks, or are they somewhere in between? Okay, so this helps students who are being evaluated to see where they need to improve. Okay, and then of course you can assign points and do things like that if you want. But nonetheless, what's important here is that halfway through class, the inner circle and the outer circle flip. So this student and this student would flip positions, and now blue would be on the inside all the way around, and yellow would be on the outside. So it's really, each student gets an opportunity to evaluate the other. They both get a chance to use all their Socratic sentence starters. But what's really unique about how we do things through KnowAtom, so if you're a KnowAtom user, you have a chance to use SocraCircle, which is a tool, a proprietary tool that we developed, which acts like a group chat. And here is an example, a screenshot from our platform. And what happens is the teacher, when they're logged in, can go to SocraCircle. They click to create a Socratic circle, and so they can name it, so on. And each Socratic circle has its own unique URL. They post that URL for the students. All the students can sign in. And then what you'll see here on the side is the student roster. What happens is that students have a student sort of version of what you see here. And the students who are in the outer circle are having a nonverbal Socratic dialogue in SocraCircle. And what they're doing is they are having the same kind of discussion that the inner circle is having verbally. And in fact, they're often adding on to those ideas, supporting the ideas, perhaps providing evidence or refuting a claim. And the students, in this case, obviously students have to use Chromebooks or iPads or laptops, or this actually even works on cell phones. But what's important here is that if every student has a device in the classroom, and even the teacher could be projecting it on the overhead as well, but every student, the students who are on the inner circle can be watching the dialogue occurring in the outer circle and be adding on to that verbally and pulling those ideas into the conversation. And vice versa, the students who are in that outer circle are, going to outside sources, pulling in visuals, doing their own sort of thing. And what's great about that is that you can have a 40-minute Socratic dialogue where you go through 3 or 4 big ideas in the first 20 minutes, the inner and outer circle flip, and then you go through your next 4 big ideas in the second 20 minutes. So the entire class has a building story to it. The big ideas are arranged along the storyline, obviously, and the conversation is always fresh and it continues to evolve. Okay, so I won't go into too much about the tools, but if you are a KnowAtom user, this is a really easy to use tool. There's all kinds of safeties, permissions, and you can see from a teacher's perspective, you can mute, star things, you can hide comments and all of that. So, it also lets you keep a transcript, which is really useful for assessment and other purposes that can be used for. So, the teacher, again, in this is only holding students accountable for appropriate engagement and helping to ensure that the group transitions through those big ideas. So where can you get these big ideas? If you're a KnowAtom user, they're already laid out for you in the curriculum, okay? We've even helped to give you some areas where you might want to consider creating some seed questions, right, around that big idea. But if you don't have KnowAtom, you're using something else, that's fine. What you've got to think of, though, what is the big idea? And the goal here, big ideas are things that are core concepts, okay? And what's happening here is that if you imagine something like a trait as being a big idea, through Socratic dialogue, what's happening is that big idea is now connecting to another big idea. Okay, something like adaptation is then connecting to something like trait, heredity, something like trait. Okay, well, if it's an inherited trait, does that mean it's an innate behavior? Well, I don't know. What kind of behaviors can we think of? Well, there's learned and inherited, and so on and so forth. So this is how that network, that web of concepts, okay, something like a finch's color, which is a trait that can be sensed with, eyes visually, which is inherited. which is a kind of adaptation which would have developed through natural selection and so on. All of these things are connected. And this is what it means for students to be able, and again, I'm not quoting a specific standard, but when they're developing and building models, and they're considering things like traits and inheritance in 3 dimensions, this is how they get to apply those science and engineering practices, those skills to that, to also do it simultaneously in a content context, developing the content, and also how they get to observe the cross-cutting concepts, okay? So if you're a KnowAtom person, we've already helped break that out for you in those units, right? So there's the performance expectation, and we're explaining how students are engaging in lesson 1, lesson 2, and so on in that unit, each of those different dimensions, right? Disciplinary core ideas, cross-cutting concepts, and science and engineering practices. And what you'll see is that part of those science and engineering practices are all things that occur first in Socratic Dialogue. They're repeated with partners through lab planning. They are relied upon as students carry out investigations, prototyping, hands-on. They're gathering that data. They are encountering the observational phenomena, right, that helps inform their ideas and opinions about that anchor phenomena. It's happening, these skills are happening again and again and again. And where are they happening? In the context of the content. What are they bringing to life? The content and the cross-cutting concepts. How are they connected? They're connected, through the nature of science itself, but they're connected through cross-cutting concepts, and they are how we actually practice or perform the expectations of the standards and develop that as a skill. Okay. All right. So I got into that a little bit, but I think it's really important to understand that that the concepts, that the big ideas are concepts, and where do the concepts come from? They're coming from the standards themselves, but you're not teaching standards in isolation. It's not covering, quote, a lot of traditional teachers will say, oh, I cover this standard in this grade level. I cover this standard in this unit. It's not a once and done like that, okay? They're taught, these standards are performance expectations that have life within a storyline that lives on beyond a single lesson or unit, and they're taught in clusters together, okay? Socratic Dialogue gives us that opportunity, the very first opportunity to encounter and develop and grow those ideas and really work with them. And when I say work with an idea, I mean work with it like Play-Doh or like concrete or like clay. Actually mold it, shape it, change it, do things to it in such a way that, you see what that idea can really do, okay, for yourself. And you compare it to others and you consider it and you gather evidence on it. So how do you get students to actively participate in this kind of Socratic dialogue? It's really important to understand that these skills, whether they're science and engineering practices or Socratic dialogue skills, it's a process, it takes time, but the amount of time that it takes is really a function of how clear and consistent you are as the teacher, communicating your expectations and coaching those students. Okay, you can go on YouTube and Google, or I guess it would be YouTube. You can YouTube Socratic Dialogue, and they're terrible. You'll see a teacher sitting down and this sort of like aimless conversation going on that really seems to have no point. And you'll see others where students are given questions and they all just ask each other questions that were given to them. Or you'll see others where a teacher, puts the question on the board and the kids all kind of go and find it in their reading or whatever. That's not Socratic dialogue, okay? Really great Socratic dialogues in terms of, seeing one is, they're often few and far between, particularly in YouTube. But the reason that type of thing is not easily dispelled is that the students have to develop the skills and the teacher needs to have the skill to develop the student skill. So both sides of the equation are engaged in some trial and error in a learning process. So you have to realize that. But what's key is that you are helping students participate appropriately. And there's some ways that you can set expectations, and which I've bulleted out for you here. One is if you are using KnowAtom or you're starting, with some anchor phenomena, is that as students encounter that they should be developing questions. If they have a question, write it down, write it in their reader, okay, write it somewhere, and then bring those questions to Socratic Dialogue, okay? All ideas are welcome. There are no good ideas and bad ideas. All ideas are welcome, okay? Some things we think are inaccurate. That's reality for everybody, young and old. I don't care what degree these people have. Everybody has inaccuracies in their understanding, but all ideas are welcome. Everyone has something to contribute to the discussion, and that students should use accountable talk techniques and also Socratic questioning techniques in a Socratic dialogue. So it's not just stuff or things like this. It's actually, you know, I don't know what you mean. Well, you don't know what I mean about what? Or what is it about what I said that you don't understand? Or what is it that I said that is unclear to you? You know, those are Socratic questioning techniques, and also use of precision. A lot of these things even start to kind of border into math practices from Common Core. So, you know, share those sentence starters with the kids. Let them pull them out. Not a problem. Agreeing or disagreeing with somebody's idea or evidence is okay. It's fine. But it's really important that when somebody's agreeing or disagreeing, they're not judging the person, because judging the person is not okay. Okay, your ideas are different than you. Okay, your ideas are not who you are. Okay, your ideas can, you know, they can change, they can morph, and so on. If I don't like your idea, or if I disagree with it, or something like this, doesn't mean I don't like you. It's not personal. Okay, that's very important. That can be very hard for students to, especially as they get into middle school, to get over. Share the floor. Obviously, not one person talks all the time. Encouraging those who haven't shared to share. And respectfully calling out peers who violate the expectations or the rules of discussion. Okay, John, I think you've shared a lot today. I'm wondering what Sally has to say. Or, you know, Juan, I know you'd like to pivot away from this point, but I think Michael hasn't had a chance to share what he said, what he'd like to say here, or what he'd like to add on. These are, you know, really important skills. Almost at the end, I got one more slide for you, and then I'd be happy to take some questions if you'd like. So concrete steps, things you can take away to ensure students make deep connections. So in addition to everything that we've talked about, I think it's really important to understand that the art of the effective Socratic dialogue means that you have no choice but to move away from fact-finding style questions. An example of that is, what is a goldfinch? You know, what's a goldfinch? What is friction? You know, who is Abraham Lincoln? You know, these sort of things. Not, you know, if Google can answer it, it's not a higher order question, okay? In general, that's probably not a bad rule of thumb to use. Also, use why, how, what models of questioning. So, you know, in the goldfinch example, well, why do you think they call this a goldfinch? Oh, because it's gold, so on and so forth. Oh, well, you know, how could being gold be helpful to a bird, or yellow in color? What would it mean if our hypothesis that males and females have different coloring, you know, what might that actually be useful for in nature? Okay, so that's an example of why, how, what model of questioning. Obviously, you would be waiting for responses and so on, but this is the way you want to train students to think and for lack of a better term, prosecute each other's ideas. Okay, to kind of hold them up and think about them, work with them. Identify your big ideas as a teacher and organize them into a storyline. So if you're a KnowAtom user, this is already done for you. I kind of showed you a screenshot. That's why they're all numbered, big idea 1, 2, 3, that's so on. And that's why when you go from one lesson to the next, the numbering continues, it doesn't reset, okay? And so a big idea, think about it as a key concept in the storyline. The next piece, create 1 or 2 higher order questions around each of those big ideas as a backup. Okay, if you're acting as moderator, what you want to do is have one or two higher order questions around each of those big ideas to help transition through them. And when you think of transitioning through big ideas, think of it as the connections. I showed you that concept map, right? The big ideas and the arrows and how they were connected. That is what your questions should be, prompting students to do. What you don't want to do is ask linear questions where it's like, are all traits inherited? Are all behaviors learned? That's linear. Okay, non-linear is more that why, how, what. Okay, it pivots at each of those sort of next questions. Create space for students' ideas. I think this is one of the most important things you have to remember, is that in a traditional model of instruction, both teachers and students, teachers haven't been requiring students to think. So you have to remember in a traditional model of instruction that students aren't taught to reason through their own ideas or the ideas of others, and especially, when it comes to arguing with evidence. Okay, so in order to get students to develop that skill, even in a Socratic dialogue, you have to create the space for it. Okay, creating the space means being okay with 10 seconds of silence, understanding that it takes time, that it requires careful listening, that you have to place aside judgment. And judgment is very, very sneaky. If a student gives their idea and you say something like, perfect, wonderful, great, exactly, these are all validating. These are all judging that student's idea. And it's actually, you say, well, that's all positive. Well, guess what? The student who was thinking the opposite, just by you endorsing that student's idea, now feels kind of stupid. Okay. And the other thing that you have to be careful of, it's very much like how surveys are developed. You have to be careful about how you ask a question that you don't automatically bias students' answers. For example, you may think about something like a presidential election. You could ask, a question like, did you vote for this person? Now, you didn't vote for this person implies something. Did you vote for this person implies something similar. Or you saying like, why would you vote for that person? Or, how could you vote for that person? It's like there are all these ways that are all sort of biased. Instead of saying something like, in any election, people have many people to choose from. Why do you think somebody might vote for one person over another? That's an unbiased way. Whether, every teacher, every person, every student even has their own opinion, right? But the way that you ask the question, it's really important that it doesn't unintentionally bias or set up an environment that does not seem like it's creating space for multiple or differing opinions, okay? So that's a big part of placing judgment aside. And the other thing is to take students' ideas very seriously. In order to get students to make deep connections and actually participate in Socratic dialogue means that you have to take students' ideas seriously. I can't emphasize this enough either, that if you don't take that idea seriously, there's no way that anyone will work with it because everybody is just going to push it off, okay? And some people, struggle with sarcasm or something like this. And a lot of people who do will say things, oh, they know what I mean, or so on and so forth. Well, maybe, but don't bank on it, okay? If you really want students to get involved, you have to take the idea seriously and work with it, okay? And I'll give you one quick example, and then I'll take some questions. And I apologize if we run over here a little bit. So, a student may say something like, if you're learning about matter and learning about states of matter, I might be learning about something like how when heat or thermal energy is added to a substance, it will change phase. So as you go from a solid to a liquid to a gas, matter becomes less dense. And so we talk about things like how, something that's less dense, like, a balloon filled with air will float on water, for example, which is more dense than air. Now, a student in a discussion might say something like, well, that must mean that ice is warmer than liquid water. Solid ice is warmer than liquid water. Now, what's really important here is that you dig to the root of students thinking around this big idea, or around what their contribution is, because what some people might say is that no, actually, ice is not warmer than liquid water. Okay, so that's the validation. That's sort of the traditional model of instruction. Teacher freaks out. Oh, misconception. Well, the more Socratic dialogue, more next generation way to deal with this is to kind of, get at it. Well, like, why would you say that ice is warmer than liquid water? A student may say, well, because ice floats on water and they're both the same substance. Well, if we've been learning that solids are more dense than liquids, then unless they're warm, they're warmed up and they change phase, that's actually a logical, unfortunately inaccurate, but logical conclusion, right? That if ice floats on water, which it actually does, that it would be warmer than water if warmth is the only thing that affects density, right? But in fact, what that student has kind of come upon is the fact that when water is an exception to the rule. When water freezes solid, it actually becomes less dense. Okay, so that's the opportunity to dispel the myth if it's not something students would have access to. But now we can ask the question, why would that be important? How is that helpful? So now we can think about why having ice on the top of a lake is helpful to fish versus having it at the bottom of the lake. Okay, and so on. So I won't get too far into it, but these are all, important things to consider, and why, having an effective Socratic dialogue is not about right and wrong and validation focus. It's about a thinking focus, and it's about getting at the root of a student's thinking and then building on that and building out and helping other students work with these ideas and refine them and to add their own. Okay. All right. So I'll grab some questions. I have some data to show you environments where, and if anyone has a question about that, I can show you how it impacts data. But I'm going to grab those questions now. If you'd like to see an example of what a next generation unit looks like, you can take a look at KnowAtom.com/curriculum. Scroll down the middle of the page and you'll see you select your state and so on. There's curriculum and reader samples there for kindergarten through 8th grade. Unfortunately, we don't produce high school curriculum at this point. You can also stay connected with these sort of resources through our blog, on Facebook, or on Twitter. And you can find additional webinars, both upcoming live and ones that are from the past that are on demand by going to KnowAtom.com/resources, or you can go to learn more, scroll to the bottom of the page. Okay. Okay, so I'm waiting for a few questions to come in. Some folks had asked to see the arc that I had shown earlier. I believe this is the arc that we're looking for. This just sort of shows that progression of the phases of a lesson. So the way KnowAtom lessons work, the way next generation units and lessons work, is that it's not a once and done, 45 minutes is a lesson. A lesson is a group of experiences that help students to gain mastery of specific elements of performance expectation into the full depth of the standard as the storylines develop. And so what you see here, these sort of 5 phases or 5 segments are actually potentially, like if you're in a middle school class, these could be 5 different days of the week. So one lesson actually would be, in more traditional terms, 5 lessons. Okay, so if you see students every day for 45 minutes or an hour or whatever, you could imagine your 5-day week as accomplishing all of the learning objectives and experiences of one lesson. Now, what does that mean? It means that you have fewer lessons in the year, at least by our definition, but they're longer. They cut more closely to the skills and the content and the cross-cutting concepts than large units that sort of sprawl over 3 months, where a lot of traditional classrooms would do 3 units a year and that sort of a model. That's sort of a more dated way of dealing with things. But the issue with that is that it doesn't cut as closely. Doing 10 things with one thing is not always better than doing 10 different things. So anyhow, let's see if there's a few other questions here. Folks are asking if they can get a copy of the webinar, take screenshots, that sort of thing. You are welcome to. If you have been on the live session, you'd like to share this with a colleague. Everybody who is, whether they are on the live session or whether they are on, receiving the recording, if you signed up for the live session, regardless of if you attend, you will receive a recording of the webinar. Okay. The other thing you can do is you can share the link that you used to sign up for the webinar, or just direct people to learn more at our website. Go down to webinars and they can find this webinar there. It's free. Throw in a email address and they'll get instant access to it. It usually takes about 24 to 48 hours after the live session in order for those emails to come out and for the live video to post. Sometimes faster, but usually not less than 6 hours. So other questions folks have regarding English language learners and this sort of thing. So English language learners are, when they're learning, and today they're called English learners. So English learners learn English verbally first in general. So because we know students are verbal first, whether they're in a sheltered English immersion program, they're mainstreamed or so on, Socratic Dialogue is a great way to get them discussing, okay, verbally. Take the content off the page, show them an image, get them discussing using the words that they have. And then what you're going to find is, and this is what we found when we've had state evaluators come in to our users' classrooms, is that both the Socratic Dialogue, but this type of environment here, and this is a KnowAtom model, but what it does is it gives students an opportunity to take the content off the page, actually engage it kinesthetically, visually, verbally, and it becomes a tool for language acquisition, because you can imagine that if you want to know how to refer to this bird, for example, nobody in the class probably knows goldfinch in Spanish, but if they want to learn the name of this, then they can use the term goldfinch, and that's also an English language word. Okay, we find the same thing happening, and I'm being a little bit hyperbolic with the goldfinch thing. It's not important that kids know goldfinch, but when it comes to other things too, like property, like smooth, soft, above, below, behind. These are a lot of words that we take for granted as English speakers, which English learners, are trying to adapt and develop. And of course, things like in front and behind are probably words they know in their own native language. But sometimes as we get more and more nuanced, the more we focus, that's where we come up with these more granular ways of referring to things that just at a student's own sort of developmental level may not just be using in their own native language. So it becomes that sort of tool. Another thing that folks have asked about is special education. Oh, and before I get off the English language learners, a tool like this is really fantastic, because you see if a student is using this on an iPad or a Chromebook or whatever, it has to be connected to the internet. But if it's connected to the internet, now a student who doesn't speak English can use Google Translate. So they can lift off of Soccer Circle what's being said, translated into their own language. It's not going to be necessarily a perfect translation, but it's going to help them as a tool to get the meaning. And then they can respond kind of translating back out, and so on and so forth. So again, it opens a world non-verbally. And one other piece some folks asked about is, why would you want students in the outer circle to be nonverbal and using this sort of tool, having a discussion in essentially a group text? Well, what we find is that students are two things, more apt to share in small group discussion. So that inner circle is a smaller group. It's half the size of the full group. Okay. So it kind of protects them a little bit, insulates them from sort of the weight of the entire group. It's only this inner circle. And secondly, the students who are in the outer circle, they get an opportunity to take risks that they may be unwilling to take verbally. It's a strange thing, but it probably doesn't surprise anybody in a Facebook, Snapchat, Twitter world that people are more apt to say things that they may not say in person or verbally. And so the same thing seems to apply, at least in our experience, in this type of online forum. So, you know, that's why this is important. And we've seen really fantastic results in both English language learners and also special ed students. You know, a way this could be applied is speech to text. Okay, a student doesn't even have to be in the same room doing this. They can be part of this chat with their specialist in the room next door, in the back of the room, whatever. If you're using Google Chrome, then you know it underlines misspelled words, and nonetheless, that person is a part of the discussion, both verbally and non-verbally. And so it takes, again, if for somebody who has a language-based learning disability, like myself, I have such a thing, it takes the content off the page. It gives it an opportunity to be something that's, you know, potentially written or typed. Gives it the potential to be auditory or verbal. It also, as you kind of picture in the scientific context, how this played into the rest of the lesson by having students leave with questions that they then, you know, build their experiments on and so on, that it involves them in something that's kinesthetic. So they get repeated opportunities to engage the concepts, you know, disciplinary core ideas, the practices, and the cross-cutting concepts, that if it was only in some kind of a computer simulation or in a textbook, which is essentially the same thing, then, you know, they'd be stuck in that sort of two-dimensional world. So anyhow, last question. A number of folks have said thank you. You're very welcome. Sorry, there's another question here. Some folks have asked about language arts and intervention settings. Absolutely. So you can use this tool. If you're a KnowAtom user, you have access to this tool. You can use this in English language arts. You can use this in social studies. You can use this in art. If you're familiar with Making Thinking Visible, the book, Making Thinking Visible, that book comes with some examples of classrooms using higher order questioning techniques to make thinking visible in their classrooms. And there's a kindergarten teacher who pulls out a piece of artwork, and she says to the students, you know, I want you to look at this piece of art, and I want you to tell me what you see and why you think you see it. And I'm going to kind of listen and record some of those ideas. So you can imagine opening up an art class by showing a piece of art and using a tool like this and saying, hey, I want you to take a look at this piece of art, and I want you to tell me what you see and why you think you see it. And I want to have a Socratic dialogue around that and see if we as a group can try to uncover some of the meaning or what the artist is trying to communicate to us, because art is actually, at least real art, is engineered communication. I won't try to say what real art is and what not real art is. But, art is engineered communication. So, and in an English language arts context, so what this does is it's now opening doors for students to say, okay, well, I see this, I think this is, why that artist might have put it there, and I see that, and so on. Well, I agree with you, I also see that. But then it goes a step further because students can now begin to say, well, who was the artist? What was that artist's life like? When did that artist live? Where did they live? What was happening at the time? And why would that have prompted them potentially to have made this statement? So, that's one way to think of it. In an English language arts class, the same thing applies to, a good quality English language arts class is going to have students not only reading, but actually considering why what they're reading was written, if that makes any sense. Okay, so that's really what separates, classic books from sort of I almost think of them like robo books, like you buy from a reading program sometimes, is like, it was made, it's kind of like cheese whiz books. The thing is that when you look at a book that was written, I'll use a high school kind of level, Grapes of Wrath, Tale of Two Cities, Oliver Twist, so on and so forth. Be any of these sort of books, and it could be a lesser known book too. I'm not saying that books that are lesser known are not classics or great books, but what I mean is that when somebody writes something, and they're not writing it to be, sort of like a cheese whiz book because it covers certain vocab, but they're instead writing it to communicate something as a work of art. What that allows us to do is to consider first, who is this writer? When did they live? They wrote this book. Why do you think they would write a book titled this at that point in time? Where they were living, when they were living, what were the current events? Okay, who would have agreed with the ideas of this book? Who would have disagreed? What could the consequences of disagreeing with these ideas have meant for the author? What would it have meant for the book? What would it have meant for, so on and so forth? Because that is, again, back to Socratic dialogue, that why, how, what model of questioning. What it does is it gets students to build a framework and work with their own ideas and the ideas of others, and then to begin building a framework for what's to come. So you could have this type of discussion as a Socratic dialogue before you actually read the book, and then as you go chapter by chapter, you could be asking the question, who would you cast as this character? When we had our initial discussion, these were the ideas that came up. Has anyone's idea changed? How has your idea changed? What are we learning about the author's view? Have we gathered any evidence that would support that this was the author's view? Because we don't always know, right? And so, that's an example there. In a remediation context, I guess, you certainly could use this. I guess, so RTI, like a response to, I think really this can be used in any context. The question is what are you trying to remediate? If you're trying to remediate, I don't know. I guess I would have to, if you'd like to share what you'd like to remediate, an example, feel free. But it certainly could be used. I think people think about remediation when they, perceive a hole, what oftentimes will be called a hole in student understanding, where, this student doesn't understand rocks and minerals, so they need, to go into that RTI group. We've identified it, and now, all they're going to get is rocks and minerals until they really get it. That sometimes can be people's definition and response in an intervention setting, but the way that this would be used to deal with a student's lack of knowledge around rocks and minerals would actually be to engage them in a discussion about it. But the thing is that this Socratic dialogue is not the kind of thing that happens among one or two students or a teacher and a student alone. It works best among a larger group. I would say, at least 7 to 10 students. You certainly can have a Socratic dialogue one-on-one, but what you lack in a remediation environment one-on-one is the other ideas which are going to help refine that student's perspective, the one who needs the remediation. So that's why the larger group gives you more diverse contributions. And so, when you're talking about the differences between sedimentary, igneous, and metamorphic rock, if you look at a picture of the Grand Canyon and it's like, wow, how do we think, first of all, why is there a canyon here? And, why do we think they call it a Grand Canyon? And students might go, I don't know, there's a river there and, it's really big. And you get these sort of things like, well, okay, what would a really big river, how could that result in a canyon? Okay, so now we start to get into the ideas of weathering and erosion. Well, how is it that weathering and erosion can create a canyon here where there's a river that runs right through our town and there's no canyon? Oh, well, it has to do with the type of earth there. Tell me more. What do you mean by that, the type of earth? Well, there is, clay acts differently than sand, acts differently than soil, acts differently than rock. And so depending on the kind of soil in the area, then you're going to have something happen when water runs over it. Oh, well, so what do you mean when water runs over it? And so, you can just keep chasing the concept, and eventually you're going to have teased out and gotten other students' perspectives on the idea that, when water runs over something, it begins to weather it, breaking it down into smaller pieces because the water in a river is carrying sediment. And also, if it's in an area that freezes, you can get weathering happening. When water freezes, it expands, gets into little cracks, expands, breaks off a chunk. Well, what does that have anything to do with erosion? Well, as that water is moving past, it's moving, so it carries that sediment away. And so that erodes, and over time and over thousands or millions of years, you get a canyon. But where there's harder rock, it doesn't happen as quickly, or where there's not as fast moving water and so on. And then you can begin to draw, parallels about, or make hypothetical hypotheses about what would happen if the same river ran over igneous versus sedimentary versus igneous, sedimentary, and metamorphic rock. How would each be different? How would we test that? What would that look like? What would we, what sort of results would we expect if we saw this? How would that be different? And then that could actually be the springboard for moving into an investigation around, hands-on, around sedimentary, igneous, and metamorphic rock, and working with tools and materials to investigate erosion and weathering. Okay, so I'm just making this up off the top of my head, but I hope this helps sort of fill out what that could look like. And unfortunately, due to time, I'm going to have to jump off here. If you have more questions, or if I wasn't able to get to your question, I will do the best that I can to try to follow up with you. And feel free to email me. I'm going to put my information back up here. Please email me with your question. My email is fvigent, F-V-I-G-E-A-N-T, at KnowAtom, KNOWATOM.com. Okay, and I'd be happy to get back to you. And these techniques, I mentioned data earlier, they are very powerful. These are some different science schools that use KnowAtom in their science, and I'll show you some from Massachusetts. In this particular school, in Massachusetts, the average advanced and proficient percentage scoring when you look at a school or district is 50%. The school added 51 points over the course of 2.5 years. This was before KnowAtom. This is after. And you can see, they nearly doubled the state average at something like 83% advanced and proficient or so, 87% over here. Okay. Why do you see dips? Changes in teacher, changes in administrator. So the students, as part of being part of a nurturing process, that retention's there, these skills persist, is I guess the point I'm trying to make. Not just Socratic dialogue skills. This is obviously, has to do with sort of like this complex storylines and vertical and horizontal alignment stuff. But what I'm trying to point out here is that when students are learning at this level, it has a powerful impact on scores. And this is an environment where there's 72% low income, 35% ELL, 65% free lunch, 75% high needs. I can show you a very different environment where there's only 20% high needs, 7% low income, and you see same sort of gains go from average. They add, double digit, I think it was 20-point gain, and that's points, not percentage change, but actually literal raw points and advanced and proficient combined. And you can see how they're able to sustain that. Why isn't it higher? Well, it takes a lot of work to refine that thinking, once you start to get up into the 80s and low 90s, but we do have some folks that perform up at that level. Same thing here. I'll show you, this is the #1 in the state. Carlisle Public Schools, Carlisle Elementary, and you can see they, I think, something like 89% advanced and proficient that year. And even in really difficult environments, I'll show you this one and then I'll let you go. This is a middle school where they were only 4% advanced and proficient the year before we came, and then we got involved and they moved to 28% over 2 years, so 24-point gain. But look at what happened to their warning and failing. It was cut in half, basically. They went from 54 to 27% of their students were warning. Still not what everybody wants to be. They, obviously want 0 warning, 100% advanced and proficient. But my point in mentioning this to you is that this is it was an extreme urban environment where the school itself is one of the bottom 8 in the state. It was 97% high needs, 87% free lunch, 95% low income, and so on. 64% first language isn't English, and they even hit most or even exceeded most of the state proficiency benchmarks, and they were even given partial credit for the ones that they were approaching. So it benefited students across all subgroups, not just students who were proficient at English, or not just students who were Hispanic, or not just girls and not just boys. Anyhow, thank you very much for your time. I hope that you found this helpful. And again, the recording will be available and emailed out as well in 24 to 48 hours. Thank you again. I wish you a good day and good luck with Socratic Dialogue in your classroom. Take care. Bye-bye.